So as we have, in our infinite wisdom, decided to call this thing the remote report, I thought I'd report remotely today because I'm traveling, visiting some customers here in Toronto, and I've got quite a cool 35th floor room that I'm staying in. So what I'm going to do today is look at some of the quite old functionality that's serving people very, very well today as they look to do new things with TeamViewer Dex and the One platform. I was speaking with a customer here yesterday in Toronto that have to deal with a lot of security vulnerabilities, and sometimes they're given a list of file hashes that they need to find and delete. They're not given file names because the file name may change. It may metamorph between one instance and another. They're not given the location of the file because it could be anywhere on a disk, on any device. So what they have is essentially the file hash and the file size, and that's about it. They need to find all files that match, and then they need to delete them.
So, slightly less formally dressed, post-edit bit going in at the beginning here, because essentially looking back at this, I noticed that I failed to point out two things. The first thing is why this was pretty much impossible for the team using other tools. So they were looking at potentially using PowerShell to do this through the One client or other mechanisms. They were actually looking to do it with the One client, but if you have PowerShell, you can obviously run it with anything that runs PowerShell. The problem with that is that if you want to find a file with a specific size and hash, you have to get the hash of every file on the disk using PowerShell. The bigger a file is, the longer it takes to get the hash of that file. So to get the hash of every file on the disk would mean opening every single file on the disk, which would hit I/O very hard, and calculating the hash of that and storing it somewhere, and then checking that store later to see if the hash that you're looking for is there and how many times and where it is and all that good stuff. But the very expensive, difficult part and really impractical part, because they really couldn't do this to hundreds of thousands of machines and millions of files on each machine in any practical way with PowerShell is getting the hash. It's okay to get a hash of one file with PowerShell. Finding a file or multiple files based on the hash across all files in a device is not impossible, but it is impractical. So I wanted to point that out first. And the second thing is that this is how you actually create an instruction or fragment, which is part of a rule or an automation within TeamViewer Dex. So essentially, this process that you're seeing here is how to create a net new function to go and do exactly what we're looking for here, which is to find a file by file, hash, and size in order to identify potential malware and remove it from the device. So now, back to me last week in Toronto.
Let's have a look at some functionality that's actually some of the original functionality from the One client way back when that's perfect for use in this scenario. This is a file system that find file by size and hash, and as you can see here, what you need to do is provide it with a file size and a file hash, and fast is a boolean true or false. If that's set to true, what we're actually doing is using the Windows file system metadata to first identify across the potentially millions of files on a device which ones have that particular byte size. Now, that particular byte size is there's not going to be many files that match a specific byte size, to the byte. And generally, if you have the hash of a file and you're looking for all files that match that hash, you know the byte size. And obviously, if the byte size changes, the hash will change. So these two things are tightly coupled. So if you're looking for a specific hash, you should know the byte size. So very, very useful thing to do here. But maybe you don't actually know the hash. Maybe you want to get the hash, okay? So we can use file system dot, for example, get files in directory, all right? And we can go directory colon C colon backslash backslash, because backslashes have to be escaped. Temp, I've got a temp folder. I'm not going to limit it. I'm not going to recurse it, whatever. I just want to get those files. Okay, so what files have I got in my temp folder? Here's the files in my temp folder. Okay, now let's say I want to get the hash for every file that's in my temp folder. I can declare this as my file list. Camel case equals that. Okay. And then there's that list, and then I can go for each file in file list, do, and done. Now there is a new AI coming out soon that will help you do this stuff actually, but this is all native scale, so it's incredibly fast. You see it took 5 milliseconds to get that list there. So what we're going to do now is file system dot get file hash, okay, for file path at file dot file name. So algorithm, I'm going to go with the MD5 hash, okay? If I can spell algorithm. MD5. Okay, and there we have it. Now, that's actually not great. It's giving me that. So what I might want to do is call that hash equals, right? And then at the end of this here, we're going to say select file name, comma, hash from at file, comma, at hash. Oh, file nominee. So there we have it. Now, the min file and max file stuff, or the min size and max size I was looking at. Here's file size in bytes, okay? So what we could do is add in a parameter, for example, and go min size, okay, which is an integer. And then another one, max size, which is an integer. Okay, and we've got quite a few things here, let's say between 4,000 and 6,000. Just at the moment there's 30 files in that folder, between 4,000 and 6,000. So instead of that, what I'm going to do is change file list so that it becomes select star from that file list where file size is greater than min size and file size is less than max size. Okay, so when we run this, we're going to be asked for a min size. I'm going to say 3,000 bytes and max size of 7,000 bytes. And now I had 30 and now I've only got 15. Okay, so I'm searching within a specific size range to find files that and get the hash of those files. So I mean, I could do this across an entire disk, and as you can see, this takes 29 milliseconds. It's incredibly fast, and we actually might want to put file size into this result. Why don't we do that? File size, right? So if we run that, and I'll take this 4258, right, and this hash. So if I go file system dot find file by size and hash, and I go size hash, I'll go rhythm. Okay, so my size is going to be 4258. My hash is going to be that hash. And my algorithm is going to be MD5 as before. I'm just going to run that one, okay, not any of the rest. So we're going to search the entire disk for this, and as it goes through and does that, you'll see how long it takes. This machine obviously has a couple of million files. I haven't given it any folder to search in or anything else, and ctemp is obviously beginning with T. So there we go. Oh, interesting. I have that file actually in 8 different places with different names, but it's the same file. And I have it in 8 different places on my disk, and that took less than 15 seconds to find all 8 of them, and it's using the fast file search function. It didn't walk the disk, didn't hit IO hard, and I can find every instance of that file across any and all folders across the entire device. And if I then package that up as an instruction, I can run that with parameters and essentially search all the devices in the environment for instances of a given file across all of the folders on all of the disks and get the answers back from tens or hundreds of thousands of devices in about 15 seconds. So that's it. Thank you for your time. Hopefully you found this useful. And yeah, working with files and hashes, useful stuff to do for security typically. Thank you. Bye-bye.